Look up. On a clear night, far from the glare of our cities, the sky reveals its true majesty. It is a spectacle that has captivated humanity for all of time. A vast, dark canvas sprinkled with countless points of light, each one a distant sun. Some shine with a steady, quiet brilliance. Others flicker, as if whispering secrets across the immense void. This is the view from our small, precious world. It is a window into an unimaginably large universe. And it invites us to wonder, what are those lights? How far away are they? And what stories do they hold? For millennia, we have gazed upon this celestial tapestry, feeling a profound sense of connection to something far greater than ourselves. This grand display is more than just a collection of beautiful lights. It is a living history book. Its pages are written in fire. Its pages are written in gravity. Every star you see is part of a much larger family. A colossal city of stars we call the Milky Way, our own galaxy. But our home is just one among billions, perhaps trillions. Each faint, fuzzy patch of light is another galaxy, a swirling, majestic island of stars, gas, dust. Each one is a universe in its own right, with its own unique character and its own unfolding story. The sheer scale can feel overwhelming, yet it is also deeply inspiring, a reminder of the endless beauty beyond our everyday lives. The night sky is a universal heritage. It belongs to everyone. It does not matter where you are from or what language you speak. When we look at the stars, we share a common experience. We feel the same sense of awe, the same curiosity. It connects us to our ancestors, who looked upon these same stars, saw patterns, told stories, and navigated the great oceans. They saw gods and heroes, monsters and mythical beasts. Today, with our powerful telescopes, we see something else. We see the raw, elegant mechanics of the cosmos at work. We see the birth of new worlds. We see the slow, graceful death of ancient stars. It is a story far grander than any myth. And so we begin our journey. We will venture into the heart of these great star cities. We will witness their beginnings in the faint glow of the early universe. We will watch them grow and take on their magnificent shapes. And we will see how they interact, how they dance, and how they sometimes collide. Slow, spectacular mergers that reshape the very fabric of the cosmos. This is not a story of cold, empty space. It is a story of life, of creation, and of endless transformation, a serene journey into the heart of the heavens. When we gaze into the cosmos, we are doing more than just looking across a great distance. We are looking back in time. The light from the stars and galaxies has traveled for an immense duration to reach our eyes. The light from our own sun takes about 8 minutes to reach us. So when we look at the sun, we see it as it was 8 minutes ago. The light from the nearest star beyond our solar system, Proxima Centauri, takes over 4 years to make its journey. We are seeing it as it was 4 years in the past. This simple fact holds a profound implication. The sky is a time machine. The further we look, the deeper into the past we see. This allows us to witness cosmic history firsthand. The great Andromeda Galaxy, our closest large galactic neighbor, is visible on a dark night as a faint, elongated smudge. The light from Andromeda has been traveling for 2.5 million years. When that light began its journey towards Earth, our own ancestors were just beginning their own journey on the plains of Africa. The starlight we see from it tonight is a ghostly echo from a time before modern humans even existed. It is a bridge connecting our present moment to a deep geological past. Every photon that strikes our retina carries with it a story from a bygone era, a message from a long-lost time. Our most powerful telescopes are our most powerful time machines. They can capture the faint ancient light from galaxies that are billions of light years away. When we look at these distant objects, we are seeing them as they were when the universe was young. We are, in effect, watching the universe grow up. We see galaxies in their infancy, as small, chaotic collections of the very first stars. We see them in their adolescence, growing and organizing themselves into graceful spirals. And we see them in their maturity, as vast, settled empires of stars. The night sky is not a static portrait. It is a dynamic, unfolding history of the cosmos, laid out for us to read. This journey through deep time offers a humbling perspective. Our own human lifespans, and even the entire history of our civilization, are but a fleeting moment in this grand cosmic story. The universe operates on timescales that are almost beyond our comprehension. Millions and billions of years. Yet, through the simple act of looking up, we can connect with this immense timeline. We can feel the slow, steady rhythm of the cosmos. It reminds us that we are part of a continuous, ancient process of creation and change. We are not separate from the universe. We are a part of its ongoing story, a brief but brilliant chapter in its epic history. It may seem strange to think of a galaxy as something that is alive. After all, they are made of stars, gas, dust, not living cells. But if we watch them over the vast stretches of cosmic time, we can see that they do indeed have a life cycle. They are born, they grow and mature. They interact with their neighbors, they change, they evolve, they fade. They are not static objects. They are dynamic, evolving systems. To understand the universe, we must understand the secret lives of these magnificent star islands. They are the fundamental building blocks of the cosmic structure. The birth of a galaxy is a quiet, gentle affair. It begins in the dark aftermath of the Big Bang. In the young universe, vast, near-uniform clouds of primordial gas, mostly hydrogen and helium, but they were not perfectly uniform. Tiny random fluctuations in density, some areas a little denser than others. Over millions of years, gravity began to pull these denser regions together. The gas clouds began to collapse under their own weight. As they collapsed, the first sparks of light appeared. The first stars ignited, piercing the cosmic darkness like tiny fires. These were the seeds of the first galaxies. Infant galaxies grew and developed personalities. Gravity pulled in more gas and dark matter. The material spun, flattening into rotating disks. Within these disks, waves of star formation swept through, creating beautiful, luminous spiral arms. Other galaxies, from violent beginnings, never formed disks. They became vast, round swarms of ancient stars, elliptical galaxies. Some were pulled into strange, irregular shapes by encounters. Each galaxy's form tells the story of its past. Galaxies do not exist in isolation. They are part of a grand cosmic web. They are drawn by gravity into small groups and enormous clusters with thousands of galaxies. In these crowded places, they interact. They can pass by in a graceful, slow-motion dance, or collide and merge in a spectacular embrace lasting millions of years. These interactions are transformative. They can trigger furious bursts of new star birth, and ultimately, they can completely reshape the galaxies involved, creating something entirely new. The life of a galaxy is social, shaped by relationships with cosmic neighbors. And so we invite you on a journey. It is a journey that will span billions of years and unimaginable distances. We will travel back to the dawn of time, to witness the very first light. We will float through the vast, glowing nurseries where stars are born. We will soar over the majestic spiral arms of a galaxy in its prime. And we will witness the slow, powerful dance of galaxies as they meet and merge. This is the story of our cosmic origins. It is the story of how the universe built the magnificent structures that we see in the sky tonight. It is a story of how everything we know came to be. Our voyage begins in the quiet darkness of the early universe, a time before stars or galaxies. We will see how the first seeds were planted in the primordial fog. We will watch as gravity, the universe's great sculptor, gathers clouds of gas and dark matter. We will witness the moment the first stars ignite, their light pushing back the darkness. These are the humble beginnings of everything, the birth of light itself. From there, we watch fragments grow into grand structures. We will see how they develop distinct shapes, spiral galaxies, elegant spinning disks like the Milky Way, elliptical galaxies, massive golden spheres of old stars, irregular galaxies, chaotic beauty shaped by neighbors. We explore the delicate balance of forces, the slow, graceful rotation, powerful winds from young stars sculpting gas, a slow cosmic ballet of creation and structure. Finally, collisions and mergers, colossal star cities drawn together by gravity. Not violent destruction, but majestic transformation. They embrace, stars passing like ghosts. Gravity pulls out long, graceful tidal tails. Encounters trigger spectacular bursts of star formation. The life cycle of a galaxy, a serene journey from quiet birth to grand transformation. Our journey begins in an age of profound and perfect darkness. Let us travel back in time, far beyond the reach of human memory, beyond the age of dinosaurs, before our own Earth had formed. We arrive in the infancy of the universe, a mere few 100,000 years after the Big Bang. There were no stars, there were no galaxies. The cosmos was filled with an opaque fog of hot, ionized gas. Hydrogen atoms, helium atoms, bathed in the fading afterglow of creation. Simple, featureless, and silent. Waiting. This period is known as the Cosmic Dark Ages. It was a time of immense potential, a blank canvas upon which the grand masterpiece of the cosmos would be painted. The universe was expanding, and as it expanded, it cooled. The hot fog of charged particles slowly began to calm down. Electrons found their atomic partners, combining with protons to form neutral hydrogen atoms. This event, known as recombination, made the universe transparent. For the first time, light could travel freely across the vastness of space. But there was no light to travel. The only light was the faint, cooling glow of the Big Bang, stretched into microwave frequencies, invisible to any eye. Imagine floating in this primordial expanse. There is no up or down, no beginning or end. You are surrounded by an endless, invisible mist of neutral gas. The silence is absolute. The darkness is total. This state of serene emptiness would last for hundreds of millions of years. It was a long, patient wait. The universe was holding its breath, gathering its strength for the magnificent era of creation that was to follow. All the ingredients for stars, planets, and life were present in this simple gas, but they were diffuse and scattered. Something was needed to bring them together, to ignite the first cosmic fires and end the long night. This primordial darkness was not a void, it was a cradle. Within this seemingly uniform fog, tiny, almost imperceptible variations existed. Some regions were just a fraction of a percent denser than their surroundings. These minuscule imperfections were the legacy of the Big Bang itself. But in a universe governed by the patient and relentless pull of gravity, these tiny seeds held the key to everything that would come next. They were the starting point for the great cosmic web of galaxies we see today. The darkness was not an end, but a beginning. In this vast, dark, and silent universe, a hidden architect was already at work. This architect was gravity. It was not just the gravity of ordinary matter. The universe was, and still is, dominated by a mysterious, invisible substance. We call it dark matter. It forms a vast, invisible scaffolding throughout the cosmos. The unseen hand guiding the destiny of the cosmos. Tiny density fluctuations were most prominent in this sea of dark matter. Dark matter felt only the pure, unopposed pull of gravity. Slightly denser regions pulled in more dark matter. The rich got richer. Over millions of years, ethereal filaments of dark matter began to form. Where filaments crossed, concentrated clumps began to accumulate. We call them dark matter halos. These halos were the gravitational anchors for everything that would follow. They were the basins into which ordinary matter would fall. Imagine a vast, invisible landscape. Hills, valleys, dark matter halos were the deepest valleys, like mist settling in a valley on a calm morning. The primordial gas drifted and collected inside growing dark matter halos. The universe began to separate, to gather into distinct locations, preparing for the first act of creation. The process was incredibly slow. The patience of the cosmos. It took hundreds of millions of years for dark matter structures to grow massive enough to influence gas. But gravity is relentless. It never sleeps. It pulls and pulls tirelessly across the ages. The formation of this invisible cosmic web was the key event of the Dark Ages. It set the stage. It determined where the first galaxies would be born. The grand structure of the universe, clusters of galaxies, superclusters of galaxies, was first mapped out in the invisible ink of dark matter, long before the first star ever shone. Within the immense dark matter halos, the conditions for creation were slowly coming together. As the primordial hydrogen gas flowed into gravitational wells, it became more and more compressed. These were the seeds of the first galaxies, often called proto-galaxies. They were nothing like the grand spirals we see today. They were much smaller, perhaps 1,000,000 times less massive than our own Milky Way. They were simply vast, dark clouds of cold gas, accumulating silently in the heart of a dark matter halo. They were the cosmic nurseries, waiting for their first stars. For a star to be born, a gas cloud must do more than just gather. It must be able to cool down. As gravity compresses a cloud, the gas heats up. This heat creates an outward pressure that fights against gravity's inward pull, preventing the cloud from collapsing further. To form a star, the cloud needs a way to radiate this heat away. In the modern universe, gas clouds are enriched with heavier elements, which are very efficient at radiating heat. But in the primordial universe, these elements did not exist. There was only hydrogen and helium. However, nature found a way. The primordial gas contained a small number of hydrogen molecules. 2 hydrogen atoms bonded together. These simple molecules were able to radiate away heat, just enough to allow the densest parts of the cloud to continue their slow collapse. It was an inefficient process, but it was enough. Deep within the hearts of these dark primordial clouds, small pockets of gas began to cool and contract, becoming ever denser. The stage was being set for a momentous event. These first collapsing cores were the very first stellar seeds. A continuous chain of events guided by gravity had transformed a microscopic ripple in space-time into a tangible, collapsing sphere of gas, hundreds of millions of years later. The patient work of gravity and the simple physics of molecular hydrogen were about to culminate in an event that would change the universe forever. The long, dark night was finally coming to an end. Deep inside the coldest cores of primordial gas clouds, the collapse accelerated. Gravity's victory was now inevitable. The central temperature began to skyrocket. Central pressure began to skyrocket. What was once a cold, diffuse cloud was now becoming a hot, dense ball of plasma. The core became a seething cauldron, reached a critical threshold. At this point, something miraculous happened. Nuclear fusion ignited. A tremendous energy released in a burst. A star was born. For the very first time in the history of the universe, a stable, self-sustaining fire was lit. This was a nuclear furnace. Outward pressure from fusion pushing outward, against the inward pull of gravity, creating a stable equilibrium. These first stars were unlike any that exist today. The first stars were colossal, giants hundreds of times the mass of our sun, incredibly hot surfaces glowing, unbelievably luminous, blasting light, fierce blue-white light, millions of times brighter than our sun, cosmic titans born into absolute darkness. For hundreds of millions of years, the universe had been silent and dark. Now, it had a voice. It had a light. Single star pouring radiation into surrounding darkness. Intense ultraviolet light expanding outward. Ultraviolet light begins to heat the gas. Ultraviolet light begins to ionize hydrogen. Neutral hydrogen clouds dissolving into ionized bubbles. The first sparks had been struck. The cosmic dawn had begun. The universe would never be dark again. The birth of the first stars was not an isolated event. Across the cosmos, one by one, then in dozens, and then in hundreds, these giant, brilliant stars flickered into existence. They were like beacons, lit in the vast cosmic night. Their powerful light began to travel outwards, carving out bubbles of brightness. A new era, the epoch of reionization, had begun. The light from these first stars had a profound effect. Their intense ultraviolet radiation was powerful enough to strip electrons from the neutral hydrogen atoms. The opaque fog was being burned away. This process, reionization, was like the sun burning away the morning mist. Bubbles of hot, ionized plasma began to expand outwards from each of the first stars and proto-galaxies. At first, these bubbles were small and isolated, but as more and more stars were born, the bubbles grew and began to overlap. The darkness was in retreat. This was a dramatic and transformative period for the universe. It was a battle between light and darkness on a cosmic scale. The fierce radiation from the new stars pushed back against the cold neutral gas. The process was not smooth or uniform. It was patchy and complex. Some regions of the universe were lit up early, while others remained dark for longer. The simple, calm state of the Dark Ages was being replaced by a dynamic and energetic new cosmos, filled with light, heat, and radiation. The universe was waking up. Eventually, after a few 100 million years, the bubbles of ionized gas merged completely. The entire universe was once again filled with a hot, transparent plasma. But this time it was different. This time it was lit from within by billions of stars, gathered into the first galaxies. The reionization was complete. The universe had been fundamentally and permanently transformed. The light had won. This new, transparent, and illuminated cosmos was the universe that we know today, the stage upon which the grand story of galactic evolution would continue to unfold.